In 7.5, we saw that in the vertex form, we can graph the parabola that a quadratic equation has. In 7.6, we're going to ask, but what if our quadratic is in this form, which is how we normally see it, ax squared plus bx plus c. And the question is, can we use this form to graph our parabola? And the answer is yes, of course we can. If we couldn't, it wouldn't be a section for us to go over. So yes, we can graph from y equals ax squared plus bx plus c, and in many ways this will actually be the easier of the two ways. Let's do some examples. Example 1, y equals 3x squared plus 6x plus 1. Well, the first thing we can do, and I'm going to go in a slightly different order because I'm going to do one thing that's very easy first, is we can find the y-intercept. And if you remember from the last section, the y-intercept is when we let x equal 0. And if x is 0, can you do this in your head? If x was 0, what would y equal? Well, it just equals 1. It just equals the number that's out there, or the c term. So the y-intercept is 0, 1. That's easy. Can we find the vertex? Well, I'm going to give you a formula to find the h part of the vertex. We're just going to go negative b over 2a. This is a formula you'll need to know. Let's plug in our numbers. Negative the b term, which is 6, over 2 times a, which is 3. So negative 6 over 6, and that's just negative 1. So for my vertex, I already know the x-coordinate is negative 1, because h is the x-coordinate of the vertex. Negative b over 2a. Solve, we got negative 1. So how can we get the y-coordinate? If I know the x-coordinate, how can I get the y-coordinate? And hopefully you were thinking in your head, just take that answer and plug it into our original equation, and you would be correct. And I will use the colors for that. So I will take the negative 1 that we just solved for as the x-coordinate and plug it in for x. Let's do some things in my head. Negative 1 squared is 1 times 3 is 3. 6 times negative 1 is negative 6, and plus 1. And if I do all of that, I get negative 2. So my vertex is at negative 1, negative 2. Now with my y-intercept and my vertex, we should be able to get that reflective point. We know the y-coordinate of the reflective point would be 1 because it's the same as our y-intercept. And what would the x-coordinate be? We should see that that would be negative 2, comma 1. We can see both from our points and from our letter A. Remember, if A is greater than 0, that this opens up. And from my vertex, this negative 1, we know my axis of symmetry, x equals negative 1. So I know it's kind of written all over the screen. I'm sorry, I'm trying to not go on to a whole bunch of slides. But you see we're checking off all of the list of things that we were able to find in the last section. We're just doing it in a slightly different order. And actually, a lot of this is easier, I would think. The last thing we need to find are the x-intercepts. So we have our equation, y equals 3x squared plus 6x plus 1. And to find our x-intercepts, we just use our quadratic equation. -6 plus minus 6 squared minus 4, a is 3, c is 1, over 2 times a, which is 3. -6 plus minus 36 minus 12 over 6. That is -6 plus minus square root of 24 over 6. That is -6 plus minus square root 4 square root 5. Oh, I'm sorry, square root 4 square root 6 over 6. That's -6 plus minus 2 square roots of 6 over 6. And that is -3 plus minus square root of 6 over 3, taking a GCF of 2 out of everything. Now we simply plug those into our calculator, and we get -0.18 and -1.82. So our x-intercepts were probably the most work, but it's nice because it's already in the form that we want for the quadratic formula. Everything else should have been pretty easy. Let's try another one. What if we say, example 2, that y equals 2x squared minus 6x plus 2? Well, again, let's start with the y-intercept because that's super easy. If I plug a 0 in for x, I'm going to get 2 for y. And that's always just right there. 2 up. If we want to start finding the vertex, we know h is -b over 2a. So we take minus a -6, be careful, over 2 times a, which is 2. So we get a positive 6 over 4, or 3 over 2. So for my vertex, we already know the x-coordinate will be 3 over 2. And I'm going to stick with fractions. Let's find the y-coordinate. We do that by plugging in our x-coordinate for the vertex. We plug in our 3/2. 3/2 squared is 9/4. 3/2 times 6 is just 9 plus 2. 2 times 9/4 is 9/2 minus 7. And that's like -5 over 2. Because 7 is like 14/2. And 9 minus 14 is -5/2. So now we have our second part, or our y-coordinate of our vertex. And let's graph that. So 3/2 would be 1.5. -5/2 would be somewhere down there, because that's -2.5. If I want to know which way this opens, I would look at the a term. A is greater, sorry about that. A is 2, which is positive, so this opens up. If we wanted to know the axis of symmetry, we get that from the x-coordinate of the vertex. X just equals 3/2. So those two, we just have to look and know. Remember, if we wanted to do that dashed line there. What else can we do? We can do the reflective point. So if my y-intercept is 0, 2, my red dot, and my vertex is 3/2, -5/2, where would my reflective point be? I will make that with a purple dot. It would be somewhere over here. Can we figure out exactly where it would be? Well, the height of it would be 2. We know that. That's easy. It's always the same as the y-intercept. And if this distance is 3/2, this distance is 3/2. Those combine as a distance of 3. So the reflective point is at 3, 2. So we have our entire list except for our x-intercepts. And again, to do that, we just use our quadratic equation. Negative b, which is minus a negative 6, plus minus b squared minus 4 times a times c all over 2 times a. So 6 plus minus square root 36 minus 16 all over 4. That is 6 plus minus square root of 20 over 4. That is 6 plus minus square root 4 square root 5 over 4. That's 6 plus minus 2 square roots 5 over 4. And that, take a 2 out, 3 plus minus root 5 over 2. Or as a decimal, 2.62 and 0.38. And that's how we find our x-intercepts. And again, that should look pretty similar to things we have been doing already. Let's do one more example, example 3, and of course it has to look a little different. And what you should notice right away is we're not in vertex form from the last section, and we're not in standard form, which we've been doing, ax squared plus bx plus c. So we need to change this to get this in the standard form. And how are we going to do that? My favorite term, FOIL. So let's FOIL what's in the parentheses, x times x squared. I'm going to do the outer 5x and the inner negative 7x and combine those, negative 2x. And the last is negative 35. Take that and multiply it by the 2 that's out in front, and I get y equals 2x squared minus 4x minus 70. From there, we can identify our terms. The y-intercept is easy. It's 0, negative 70, because it's always the last thing. Let's go ahead and graph that, and obviously I'm not going to count down 70, but I know it's somewhere way down here. Let's find the h term of my vertex. That's negative b over 2a. That's negative a negative 4 over 2 times 2, which is a. That's 4 over 4, which is 1. So for my vertex, at least we know we have a 1. We take that 1 and we plug it back into our equation. I'll do that over here. And I'll keep with the blue theme for h, or x in this case. So 1 squared is 1 times 2 is 2. Minus 4 minus 70, and that looks like negative 72. So our vertex 1 and negative 72 would be about there. We can look at our a term. I'm sorry, right here. A is 2, which is positive, so this opens up. We can also look at our vertex and know our axis of symmetry is x equals 1. If we wanted to draw that dashed line, we could. Using that dashed line and my y-intercept, we should be able to find out our reflective point. If my y-intercept, my red dot, is 0, negative 70, my vertex is 1, negative 72, my reflective point is somewhere over there, and more exactly, it's at 2, negative 70. Well, that leaves the last thing for us to do as the x-intercepts. Let's do that. We have y equals 2x squared minus 4x minus 70. Use the quadratic equation. Negative b, which is minus 4, plus minus, square root, negative b squared minus 4 times a times c, all over 2a. That is 4 plus minus square root 16 plus 560 over 4. That is 4 plus minus square root of 576 over 4. That's 4 plus minus 24 over 4. So that's either 28 over 4 or negative 20 over 4. So that is just 7 or negative 5. And that's it. So if we get it in the standard form, we can find all of the graphing pieces that we found with the vertex form. And in fact, they're actually easier.